One of the difficulties when working with Stable Diffusion models is understanding how the many different parameters might affect the final output of an image. One way to make sense of it all is to use the XYZ plot available in Automatic 1111's Web UI. This video will be going over how this script can be used to fine-tune an image to your exact liking. So in our example, we're going to be using the Stable Diffusion XL base model. I went ahead and already added a prompt, added the width and height, and then have hard-coded in a seed value. You can find the XYZ plot under the Text to Image tab, and if you scroll down until you see the script label here, you can go ahead and click on XYZ Plot. So first up, I want to see how the seed value impacts the composition of an image. We're going to go ahead and look at a range of them. So we're going to just look at, say, the next 5 of them and how the image changes. So if we put it in this range value and just go ahead and click Generate, we'll go ahead and get our plot with the 5 different images. Now it's important to note here that when using XYZ plots, they can be very resource intensive. The reason being is that it's drawing a new image for every value on the plot. So in our example where we're looking at 5 different seed values, it's drawing 5 completely new images that it's plotting on this axis here. So now that that has generated, we can see our plot with the different seed values. Again, we have our original image here at 941, and then we can see how the next 4 images would appear. Another way that you could use the XYZ plot is to look at another feature. So for example, if you look at the variation seed and variation strength, that is basically a way to mash up 2 images against one another. So say for instance in this XYZ plot, I kind of liked the house, or perhaps I just like the garden without the road. We can actually have the XYZ plot compare or mix up both of these images side by side. So I'm going to go ahead and take out my original range that I was looking at the seed values here and just put it in this second image. And then you can do the variation strength. So that's a float value that goes between 0 and 1. And so I'm going to go ahead and look at it on 0.25 increments. So we'll go ahead and click Generate here. And then this will go ahead and produce images that will kind of gradually mix up between these two. Now at a value of 0, I should have my original image, and at a value of 1, I should have my completely different seed value as the image. Okay, so now that that's done, we can see how this image changes when playing with the variation strength. So as expected, at 0 it's our original, and at 1 is our new image. And we can see that this road kind of becomes like a little sidewalk, whereas like say the flower bed is a little bit more pronounced, or probably pulling from this image where it's a larger focal point. The house itself also slightly changes throughout time, so it's a really cool way to kind of say, you know what, actually I kind of want this one here. So that's with the variation seed and strength. Now as far as the CFG scale, you can easily compare that. Basically this informs how closely the model should follow your prompt when generating the image. A higher value will make it more strict when following the prompt. So if, say for instance, you wanted to see between a CFG between 5 and 25 and in increments of 5, you can easily do that here and then generate the image. Okay, so now that that's done, we can see how the CFG really impacts the image over time. And as expected, typically with higher CFG values, the image will become much more saturated, as we can see here at 25. Typically anything in the range of say 7 to around 15, 16, somewhere in this range are going to be mostly your sweet spot whenever it comes to CFG values. But you can also see here 20. It's not too bad, whereas 5 is a little bit too muddy. But again, if you want to kind of see how that scale impacts your final image, it's a great way to use the XYZ plot for that, instead of generating each image one by one. Now, let's get a little bit more creative here. So the XYZ plot has this cool little feature called Prompt SR, which stands for Search and Replace. So I used Golden Hour to inform the model that I kind of want that cool, warm, summer's evenings glow. But let's go ahead and play with that and actually change that out. So with search and replace, you always put in the value that you're searching and replacing first. I'm going to go ahead and put in, say, morning, midnight, and rainy. And so what I'm expecting to see here is a fairly similar image, but with different type of weather conditions or different times of days. Okay, cool. So we can see our original image with golden hour, and then we can see kind of a morning image, a midnight image, rainy. Really, really cool, powerful way to quickly change the mood of an image by just using that prompt search and replace. You might want to do this for all sorts of different ways, whether it's changing out the artist or art style, or say, instead of saying 8K, you could try best quality, 4K, and see kind of how it impacts your final image. So that's with the search and replace. Prompt order is also a really cool feature that I'm currently digging. So that actually will change the order of the prompt and how those values are in here. So for instance, if we want to look at, say, clouds and flowers, intricate, and countryside. Now, I would recommend never putting more than 3 values into here, because if you have a very long prompt, it will create a massive image. So we'll just keep this short with just 3. Even then, that's kind of pushing it, as you'll see here in a second. But basically, and I'll go ahead and click generate because it's going to take a while, is it's going to be changing where, say, the word countryside is. So it's going to do countryside here in this first position, and then clouds and flowers, it will move that. So it's basically creating like a little matrix that will be moving each of these terms around, and you will see how that will affect the final output of the image. Okay, so here's our final image, and we can see here if we have clouds and flowers at the front, whereas if we move it a little bit further back in the image, we'll start to get similar features because we didn't remove the prompt at all, but we changed the composition of it by what we're accentuating it. Because with Stable Diffusion, it puts more weight on what's at the start of the prompt than what's at the end of the prompt. So while this image and this image might look fairly similar at first glance, but they are a little bit different. So we can see intricate still in the second position within this list, but countryside is now first and clouds and flowers are second. While we still have clouds and flowers between the 2 images, we can see it starts to bring in these hills or this countryside atmosphere to it, where this isn't at all prevalent in this original image. And while it's a subtle difference, it can definitely make a big change, especially if you have a longer prompt and you are moving some of the words, if you're using 75 tokens in your prompt and you're moving something all the way from the back all the way to the front, you can really see how it would impact the final result of the image. So perhaps with longer prompts, this can be even more powerful if you are only testing out a few X values. So next up, I want to test out the sampler. So sampler is one of those things that leads to a lot of questions about all these different sampling methods that are available. We can see this long list that's used to kind of figure out whenever drawing an image within Stable Diffusion. So the default here is the DPM plus 2M Kara. So we'll go ahead and put that in here. And I want to see how that, say, is different from Euler A. And then, you know what, we're going to go ahead and just try one of these other ones. I have no idea. I've never used this one before, but let's go ahead and take a look at how this affects the final output of the image. Everything else is the same. We're keeping the steps at the same because these do have a direct impact on the sampling steps, because some of these sampling methods might be a little bit more efficient than others. But just on a raw output at 20 steps, we can take a look at what the XYZ plot shows us and how the sampling methods can impact the final output of the image. Okay, so here's our output between these different sampling methods, and as you can see, completely different images based on the sampling method. So you can definitely play around with this and kind of figure out what will work best and what gives you the best sort of composition or style that you're looking for when generating images. And of course, as I was talking about earlier, is sampling steps play a huge role with these sampling methods. So if you want to, you can actually just add that in here. So I'm going to go between 1 and 20, and I'm going to go in, just because we're going to make it a little quicker here, is we're going to go in 5-step, or actually we'll go in 4-step increments, and kind of see how that impacts the final image. So with different sampling methods, some might not need to go the full 20 steps, or some might need to go further than 20 steps in order to produce a really good result. So you can kind of see how one sampling method might perform versus another in the number of steps that they are produced. So you can really fine tune this and perhaps go with shorter step increments between them in order to figure out which one will work best. Okay, so here's our outputs for the different sampling methods and the different steps and how they kind of evolved and created the image. Now I know this is a little bit smaller on my screen, but we can see here how kind of the image develops over time based on the number of steps and the sampling method, which is pretty neat to see because you can really kind of see the image start to develop and take on much more intricate details as it goes through each of its steps. Pretty cool. So when looking at the XYZ plot, there are a lot more things that you can compare. I mean, we are only scratching the surface. If you wanted to try different VAE, you can, or if you want to try different models or checkpoints, you can. Now, I would caution if you're comparing checkpoints, it's important to know that there are fundamental differences between the models, such as how they understand images and the types of prompts that they expect to receive. But if you'd like to, you can use different models and compare those, and so much more whenever it comes to the XYZ plot. So with that being said, I hope that this video was helpful in kind of giving you an overview of the XYZ plot, how you can kind of adapt it for your workflow in order to generate images, hopefully a little bit better or more what you would like to expect from these really powerful models. Of course, if you have any questions, feel free to drop a line in the comment section below. I'll be more than happy to try to help there. And if you do like the video, please hit the thumbs up and also consider subscribing. Thank you so much for watching, and I'll see you guys in the next one. Take care.